All right, now just a little review here. We won't spend too much time, but I just wanted to review what happens when we have a horizontal line or a vertical line, right? The slope of a horizontal line is 0 because if we were to use rise over run, we would have 0 rise and all run, right? So in this case, it would be like 0 over 1, right? Because our rise would be 0, but our run would be 1 from left to right. So whenever you have a horizontal line, the slope is 0, okay? Horizontal lines always have a slope of 0, okay? Now vertical line here, if we were to put this into a slope formula, we would have a rise of 2 and a run of 0, right? And so that's undefined, right? Because we can't divide by 0. So slope is undefined when we're dealing with a vertical line. Okay. All right. So just remember that those are our special cases, and hopefully, you remember those. If you don't, just you can draw a picture or use your formula and try to conceptualize it that way as well. All right, so now let's say we're given 2 points, but we don't have the graph, right? So one thing we can do is we can definitely graph these, right? So we can just put this on a graph, and then we can use the same method that we used before and visually figure out the rise and figure out the run. However, we have a formula that allows us to bypass the graph, right? So y2 minus y1, that tells us the change in y. And x2 minus x1, that tells us the change in x, okay? So that's another way to find change in y and change in x if you're just given points, is you can just plug them into the slope formula, all right? And so let's practice using this for a little bit. So first of all, identify your x and y's in terms of 1 and 2. So I usually just start and just call the first one x1, y1, okay? So make sure that your 1's are together, and then x2, y2, make sure your 2's are together. All right. Now, just for review, x comes first, y comes second always, right? And so x is always the coordinate on the left, y is always the coordinate on the right. Okay. So now I can plug this into my formula. So what I'm going to do is, and let me color code this a little bit better. All right, so I color coded. So now x1 is 19, right? So I'm going to put and y1 is negative 16. So, and we start out with actually y2, right, which I have in purple here. So y2 is negative 15. Okay, so it's y2 minus. Notice how the minus is built into the formula, right? So this minus is here no matter what. And then I'm going to put y1, which I happen to have in blue. Okay. So y1 is negative 16. So I already had a built-in negative there, and then I'm putting negative 16 behind it. Okay, all over, and then on the bottom we have x2 minus x1, right? So x2 is red here, so negative 7. Then we have another built-in negative here, so I'm going to put minus, and then x1 is 19. All right, and I'm going to put that in green. So I'm going to put 19 here. Okay. All right. So y2 minus y1 on top, x2 minus x1 on the bottom. And so here we end up with negative 15. We have minus a negative, so that turns into a positive, right? A negative negative turns into a positive. And so negative 15 plus 16 is positive 1. And then on the bottom we have negative 7 minus 19, which is negative 26. Okay, so that would be the answer to this question. The slope would be negative 1 over 26. All right, so let's try number 3. So let's identify here. We have y2, or sorry, we have x1, y1, and then we have x2 and y2. right? And so we're just going to plug them into this formula here. So m equals, and then we have y2 on top. So I'm going to put -4 minus, and then y1 is 7. So I'm just going to put 7 in there, right? Got that from here, all over. And on the bottom, we're going to put x2, which is -6 minus, remember the minus on top and bottom are built in, and then our x1 is -4. So it's going to be minus -4. So remember, a negative turns into a positive, and so what we end up with is -4 minus 7, -11, and then on the bottom, -6 plus 4 is -2. And so we have a negative over a negative, so that can be simplified, right? So we always want to simplify if possible, and so that turns into 11 over 2. So that's our slope. All right, so go ahead and try out number 2, okay? All right, so if you got -4, great work. We had 12 over -3, and when we reduced that, we ended up with -4, okay? Now, one thing, it's okay it doesn't really matter which ones are your 1s and your 2s, as long as you keep your 1s with your 1s and your 2s with your 2s. So in other words, if you have, like, if you make this x2, that's okay as long as you make this y2, right? But if you make this x2 and this remains y1, then that will give you a sign error, okay? So just, and I would just recommend just doing 1s and 2s this way, just because then you don't have to think about it too much.